Hello students, all of you welcome at Physics Point. So in today's lecture, student, I'll start ray optics, right? So I can see ray optics its own significance in J. Uh, I can say student in mains at least one question you will get, minimum one questions, probability for two questions. And but advanced at least one question student, at least one questions. And in advance they can ask question like good questions, good variety, good level of the question. So without wasting time student, how I'm going to start the class as usual. This is what I can say, three optics. So beta today class, maybe it's a fundamental, theory is more for today class, numerical is less. So keep in mind, uh, and stay and follow physics one regularly. So what's the point which is I have to just start the class. Just give me at least 1 minute, students, so that maximum student can get benefit of this point. Okay, fine. So now, student, I'm going to start the class here as usual. So first, student, ray optics. What is ray optics? Ray optics is what? Student, first thing, what is ray optics? Beta, what is ray optics? So this is ray optics is basically study of light. What, my dear? Ray optics is basically study of light. That is the first thing which we keep in mind. Now we can ask, sir, why study of light? These all are means today classes. I'll just go through maximum theory part. Why? You can ask, why study of light? Okay, so because in answer you can go like that. Students in answer you can write because light is those part of light is those part of electromagnetic spectrum. Light is those part of electromagnetic spectrum which is what, my dear, which is visible to us. What, my dear? This is visible to us. Okay. Or you can also say, students, which gives us sensation to our eyes. What is friend? You can say why study of light? Because light is those part of electromagnetic spectrum which is visible to us, or you can say which gives us, or you can say which gives us what sensations to our eyes, right? So you can say usually with a range of light for visible region. Students can write a range of light for this. Taking consideration. I don't want to leave any weak point of ray optics, so that you can easily understand, my dear. Okay, so but there is little some variations. We'll get somewhere, but student let's Srisha. So this is 3600 angstrom to 7800 angstrom, right? Okay. But now yeah, I wanted to discuss about little because you can ask, sir. What is electromagnetic spectrum? Right. So students here I can write electromagnetic electromagnetic spectrum. Electromagnetic spectrum. So this is what, my dear? First radio wave, then students microwave, then beta ji infrared, beta video, or you can say visible region beta. Next UV, X-ray, gamma ray, and cosmic ray, and so on. Right, my dear? So here's one question here. I wanted to ask to everyone, those who watching me currently. Beta, if your motion, take in consideration, if your motion radio wave to X-ray, so you have to comment. You have to comment, beta. Wavelength increases or decreases. You can write your answer in chat box. If your motion, I can say left to right, so wavelength increases or decreases. So answer is what, my dear? Wavelength decreases. Beta the frequency increases. So now this is beta first questions. Second questions I'm asking to everyone, those who are watching currently. Uh, Student, you have just answered me. Energy increases or decreases? Student, you have just answered me. Increases. Energy increases or decreases? Energy increases or decreases? Anyone can answer me? Those who are watching. Okay, someone. Energy increases. Correct. Correct, student. Because I hope you knew the formula. That is, students, you can use. E is equals to beta, you can use. E is equals to Hc by lambda. Right, my dear? So what you can say? Lambda decreases. Your answer correct, beta. Energy decreases. So what you can write, beta? The energy increases. The wavelength decreases because what you can say, both are reciprocal to each other. Beta, what you can say? Reciprocal to each other. Okay. Now, beta, I wanted to add one more point here. What is the key word for light? What is the key word for ray optics? Yes, beta. What is the student key word for Hare Krishna Advik beta? I'm very happy to see, my dear. Key word for ray optic. Student, what is the key word for ray optics? So what's answer, my dear? As answers, you can say nothing but sir. It's light. Nothing but what you can say, my dear. It's basically light. Right, beta? Okay, fine. Beta, now here, I'm going to discuss in detail the optics. Advik, beta, just take snapshot. Student, just I explain these all points. So take snapshot, my dear, and maintain class notes, beta. It's highly required. Will help you a lot. Advik, how was your paper? Study and Advik, what about your study paper? Are you getting benefit of this live stream classes? Okay. Beta, is there any contribution of live stream classes? Are you getting benefit of live stream classes? Oh, wonderful. Wonderful. I'm proud of you, beta. Very good. So you have to answer me, beta, Advik. Oh, very good. Yes, 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 yes. Why I'm asking beta, Advik? Because no, yesterday, beta, I was traveling somewhere. I was coming back my home. So on the way, there is one parent, I can say, wants to talk to me. She wanted to talk to me, and she conveyed one point. She said, "Sir, because of live stream classes, my kids nowadays very comfortable in physics. Is this right, Advik? What's the opinion of you?" She said, "Because of your live stream classes, my kids nowadays very much comfortable in physics. Is this right to say?" Okay, good. Means your opinion also remains same only. Yes, beta. I can say, beta, Advik, I saw paper from someone. Uh, oh, very good. So I can say, Advik, beta, someone said, uh, yes, correct, correct. Very good. Beta, no, literally, Advik, someone said, like, na, question number 45 and 50, beta, I did get in classroom, but but I solved question in streamlined classes. I solved beta that question is stream. I can see live classes here. Uh, so it's literally I'm looking here for more growth, for more questions and more clarity in concept as well. So yes, beta. Keyword for ray optics. Beta, what we can see light. Now, beta, put the heading here. Domain of. I hope beta you have taken the screenshot, beta. Advik, I hope you have taken screenshot. Okay. Actually, I'm looking your reply. Okay, fine. So now we have put the heading here. Domain of ray optics. Don't write bacha. I'll give time bacha party. Listen me first, my dear. I'll give time to write bacha party. Don't very hurry. Don't hurry bacha. Because this is the platform. I'm looking for your growth bacha. This is class only for growth only in subject knowledge. So listen first bacha. I'll give time to write. So what's next heading, students? This is uh, domain of beta ray optics. What, my dear? Domain of ray optics, right? So, beta, this condition, what we can think? What's the meaning of this domain? The study of light can be categorized into three broad domains. Yes, beta. Means to like now we are calling types of flow. So, behalf of this, I'm telling for sake of convenience, you can easily connect, my dear. So, domain of ray optics, what you can say, the study of light. What student? The study of light. The study of light can be categorized. Can be categorized. Categorized into three broad domain. Three broad domains. Yes. Yes, beta. How many beta? Domain of we have to categorize in what? Three broad domains. Okay. So beta, this is first one. Are you beta note beta with me because time is less now. Theory point beta we can cover together only. 3 point beta we can cover bacha. Okay. हाँ बेटा आदि because time is this बचा party. Geometrical optics. This is what, my dear? Geometrical optics. So we can also see here. This is ray optics. Ray optics. Beta, God bless you for your reaction. Now, beta, options number just what it because I said domain of ray optics divided in three categories. This is geometrical optics. Second, beta, you can say physical optics. So this is beta. Uh, we will learn in 12th class. Wave optics. And last bit I can see uh, geometrical wave and quantum physics. Third one. These all are domain of reoptics only, bacha. So what is third one? Quantum physics. What we can say? Quantum physics here. Again, you will learn this concept in the student modern physics, 12th class. This is what my dear modern physics, 12th class. Okay, now I'm going to discuss what is geometrical optics. Yes, so I can say geometrical optics. No, beta. Wavelength of light is wavelength of light is what? Very much less with respect to what I can see, size of obstacle. Beta, this is what which I can say. This is size of divided what you can say, size of obstacle, right? Next, what's authority? What you can say, quantum physics. Beta, what you can say, quantum physics. Next, physical and beta. So next, we can take in consideration that is physical optics. So there is what is wavelength of light is very much large with respect to d. D is what size of obstacle. D is what my dear you can see size of obstacle. So that's Sham. D is what my dear you can see size of obstacle. If you are really liking beta session here, at least beta one like and so reaction beta regularly. Okay. Now beta let's move next. That is what my dear quantum physics. Ah, okay. So now, beta, what is quantum physics here? Study of propagation of light. Study of propagation of light as a stream, as a stream of particles, stream of particles called as photon, called as photon. Necessarily, beta, these all things here you will remember, you will learn in beta. I can say what my dear basically beta G for in the chapter of modern physics. Okay, so you know what is things which we will discuss over here means not here in modern physics beta. That is what my dear photoelectric effect. Photoelectric effect. Concept of radiation. Concept of radiation pressure. Concept of radiation pressure and beta quantum effect. And students, this is quantum etc. Okay, these are the points, my dear. Okay, fine. Now, beta, I'm going to discuss. These are the points. I discussed only what I can say domain of ray optics. We have a three domain of ray optics. What's the first one? Geometrical, physical, Hare Krishna student,
And next beta what we can say, that is what quantum. So I explained what it is all. Now beta I'm going to introduce, that is what I can say my dear, basically fundamental laws of geometrical optics. Yes beta, this is fundamental laws, fundamental laws of geometrical optics. But I know because in our syllabus mentioned only with geometrical optics, right? Okay, means your grade, for this grade beta we have to discuss only what geometrical optics my dear. Okay, so geometrical optics is based on, it has a geometrical optics is based on what? Five fundamental law. What is it? Geometrical optics based on what my dear? Five fundamental law. Okay, so this is beta, I can see first one, geometrical optics based on beta, again I'm repeating, five fundamental law. So this is first one was the law of, this is what my dear, law of rectilinear propagation of light. Rectilinear, law of rectilinear propagation, law of rectilinear propagation of, law of rectilinear propagation of light. Okay, so here students, simply you can say, if any light, if light traveling, beta g, listen carefully, what is the meaning of law of rectilinear propagation of light? It states that light propagates in a straight line in a homogeneous medium. What a student? Light propagates straight line in what? Homogeneous medium. So this is what I can say statement which we can conclude, and which I can say given by the what? I can say law of rectilinear propagation of light. So you can just note down with me everyone. It's a theory class beta. It states that beta g, it's state that light propagates straight line, light propagates in straight line, in homogeneous medium. But this is a point here which you can keep in mind. Medium should be homogeneous. It states that light propagate in straight line in homogeneous medium. Yes, this is the first point. So let us suppose you can take, you are talking about air. So if a light falls over here, so ray will propagate like this. Simple chapati. Okay, next beta, law of independent, law of, I hope it I have written with me only. Okay, fine. So now next exercise, law of, because I have finished first law only. Second beta, law of independence of light rays. Second student, law of independence, law of independence of light law of independence of light rays. Okay, good beta Mayadvik. Okay, beta what you can say, law of independence of these all point. Now just I'm gathering all points. These all point will help you to do good questions. These all points will help you to do good questions here. So law of independence of light rays. Okay, what is the meaning of that? It states that rays do not disturb each other upon intersection. But I can say here, one ray coming like this side, one ray beta going from this side. So if they are what I can say, which are intersecting each other here. If ray is what intersecting each other, so there is no such effect. There is no such effect, my dear. Okay. Now, beta. So this is. But now I'm going to discuss. I can say law number three. Law number three, beta. So what we can say, law of reversibility of light. Yes, beta. This thing, just I'm explaining, my dear. Further, I'll use beta directly. Law of reversibility. Law of beta reversibility. Reversibility. Okay, beta, what is the law of reversibility here? Beta, you can say for law of reversibility of light, law of reversibility of light, law of reversibility of light. Okay, acha bhati, for this condition, you can simply say, bacha, it states that now any rays, ray after reflection, you can say bacha, ray after number of beta, you can understand like this. Let us suppose you can take as a mirror. This I'm taking diagram. I'm taking my diagram beta. You can say this is. Let us suppose ray falls over here. You can take this is mirror number 1. This is beta. You can take mirror number 1, my dear. This is mirror number 2. So ray beta mentioned. Let us suppose ray falling on I can say mirror number 2 at 90 degree. Beta, this is what you can see incident ray. Light beta again here, just go back on a same path. So this is what you can see. Light is following law of reversibility. Light is following beta what you can say law of reversibility, right? And beta I can say law of reflection and beta last you can see this is third law. Next beta this is what I can say law of reflection, which I'll discuss in detail. Law of beta G, this is a reflection. In fact, you can say this is 4. And the last one here, I can say, my dear, law of refraction. Beta G, law of refraction. Now, students, I'm going to discuss one by one. Now, student, I'm going to discuss one by one this all beta. First, I'll discuss law of reflection. You can see this week we have what? Only law of reflection basically. Because this week what we have only law of reflection beta. So I'll discuss law of reflection only now. Okay, beta, before proceeding beta, before I can say going to proceed law of reflection, I wanted to discuss very few points, very basic few points which are. Everyone make notes with me because this is a theory class, so I'll not give much time to write. Right beta. So now beta, just put a heading beta. This is what, my dear, basic definition. Beta, what we can see, basic definition. Okay, the light. First beta, we have to talk about light. We have to talk about light. Light, beta, note down with me everyone. Light is a form of energy. Light is a form of energy that enables what, my dear? Light is a form of energy that enables us to see object when it gets reflected from them. So light is what also gives us what you can see sensation, our eyes to see any object. Light also gives us sensations to our eyes to see any object. Okay, now we have to must discuss Now I can see theory points. So this is what, my dear? Properties of light. This is what, my dear? Properties of light. Okay, so everyone, now onwards listen here. Now onwards, beta ji, listen here. Just give me a second, bacha. My gate is opening here. Yes, my dear. We continue, everyone. So now, what is the property of light first, bacha? As I said here already, light is a what? Form of electromagnetic wave. What is, student? Light is form of beta electromagnetic wave. Who said beta? You can say beta, this is proposed by Maxwell. Beta, what we can say, proposed by what is it? Maxwell. Okay, now beta, if light is a form of electromagnetic wave, now I'm just explaining, I can say beta, properties number one of light. It consists of what, student? Consists it consists of varying electric field and beta what? Magnetic field. Simple, yeah. What's the meaning, bacha? No, beta, in electromagnetic wave, electric field and magnetic field must should be what, beta? Both are always 90-degree. So we can take in consideration, my dear, this is electric field, this is magnetic field. So we can take, this is what propagation of light. Students, you can take in consideration, this is electric field, my dear, this is a magnetic field. So this is what you can say, propagation of light. This is what beta, directions of propagation of light, my dear. Okay, bacha ji, next point here. What is the next point? I hope you have written. Please now beta, during properties, bacha, listen and writing both you have to manage together only. Okay. Now bacha, if you are liking, then you can tell me. I will stay. Beta, I wanted to turn the page. Should I do, or you wanted more time? Okay. Should I do, beta? Okay, fine. Now beta, next point here. I can say beta, this is the point number second, my dear. Now beta, this is point number 2. Light carries energy. Light carries energy and momentum. Student, just now I started here, so I'll not be in a hurry, bacha. Light carries energy and momentum. I'll do, bacha. Stay listening. I'll do all the questions. Light carries beta what? Energy and momentum. Okay. So you can write, bacha, E is equals to hc by lambda. This is first beta momentum. You can write P is equals to h upon lambda. What, my dear? P is equals to h upon lambda. Okay, beta. This is point number second, beta. Point number third, beta ji. You replied, beta, very late, beta, Advik. Okay. In other medium of light, beta, speed of light in air or vacuum. Student, speed of light in beta G, you can say air or vacuum. This is what beta you can say. uh, Bacha ji, you can simply write C is equals to 3 into 10 to the power 8 meter per second. Right, beta? Beta, point number 4, my dear. In other medium, speed of light. In other medium, speed of light, beta. What you can say? In another medium, speed of light V is equals to C upon mu. What, my dear? You can write V is equals to C by mu. Right? Okay. So what is mu, bacha ji? What is mu, bacha? It's a refractive index, my dear. I'll discuss more about this quantity later. Just now, beta, you can write mu is equals to beta of speed of light in vacuum upon beta G speed of light in medium. Beta, what you can say, speed of light in medium, right? Okay. Now with Chapati, this is beta point number 4. Beta, this we have to discuss point number 5 for properties of light. Light is what, beta, as I said, form of electromagnetic wave and transverse in nature. Bacha, light is what? Student, light is a student form. Light is a form of electromagnetic wave and beta and transverse in nature. And bacha ji, transverse in nature. Okay, but you can ask, sir, why transverse in nature? You can ask beta ji, why transverse in nature? Simply, beta, you can say light is considered a what? Transverse wave, because the vibration of its electric field, students, the vibration of electric field and magnetic field oscillates perpendicular to each other, and direction of the wave is what? Propagation. Direction of the wave is what? Propagating. Bacha, why light is a transverse wave? Light is considered transverse wave because vibration of electric field and magnetic field oscillates perpendicular to each other. Direction of propagation of wave. Direction of propagation of wave. Direction of propagation of wave. Now, beta, have a look next year. So, beta, this is the things, beta, which I said, properties of light. Beta, one more point, beta. That is what in note here, you can note down. Because, beta, this is the things one time asked in beta J Advanced 2017. J beta J Advanced 2017. Right? It's beta comprehension questions. What, my dear? It's a comprehension questions. Okay. So beta, what's the thing here? This can answer me anyone if you know, if you already know these questions. Bacha, refractive index is, beta, fill in the blanks, for meta materials. Refractive index is, fill in the blanks, for meta materials. Anyone answer me from all of you? Those who watching the video at this point. Okay, anyone answer me? Refractive index is for meta materials. Okay, now beta, I'm giving answer of this question here. Beta ji, refractive index is negative. Is what? Negative. Yes, beta. I'm telling you, my RP beta. Refractive index is negative for meta materials. So that is keep in your mind. Refractive index for meta material is what? Negative. Acha. Okay. Now students, I'm going to introduce your next concept. Now onwards, listen here, Advik. This I can see 2 minutes. Then beta, I'll give time to write. What my dear? This is next one. Relation relation between speed of light. Relation between speed of light, frequency, frequency, and wavelength. In fact, you can say speed of wave, not light. Students, speed of wave. Relation between speed of wave, frequency, and what? Wavelength, my dear. Okay. Now, students, just taking consideration, beta. Taking consideration. Let us suppose wave is propagating like this. Let us suppose beta wave is what? Propagating like this. Okay. So beta, I hope all of you remember this thing I taught during I can say bridge course, as well as student I can say like JSO preparation. So beta, this is what? Tell me. This is crest. Trough. Okay. Now beta, this is what I can tell. It's what? Wavelength for one complete loop. What distance between crust and trough is what you can say, bacha, or one loop, which is equals to wavelength. Now student, I wanted to write here formula of speed. Sir, upon crust. Correct. Beta, I can say meta material. It's beta name of different variety of material, bacha. Suhang beta, hello. Right. So beta, meta materials student, it's what you can say. Nature of beta, you can say basically materials. They will mention the question itself. Right. It's a beta simple, you can say name of the material. Okay. So you can write beta, but speed is equals to what beta? This is distance per unit time. So what's the distance traveled by? I can say bacha, for one complete loop, that is lambda beta. So you can say V is equals to lambda by t. Now beta, you can say 1 by t, which is equals to beta what you can say. This is what basically frequency. 1 by t beta, what can I write? This is what beta you can say frequency. So this is beta I can write here. V is equals to lambda into f. V is equals to what beta you can write? Lambda into f, right? Where t is what will say party? T is time period. T is what, my dear? T is basically time period. Okay, fine. Now just note down here all points beta Advik and reward me bacha. Then I'll start with the next topic. Okay. I hope it all of it are here. Should I continue next? I have to go. Advik, you can go beta. Go beta. Then you will free. Then beta you will come back. Then bacha you can watch beta recording. I'll upload it. Student, I'll update. Means I'll upload on YouTube as usual. Bacha, you can go and watch it. Right? Okay. You can go, bacha. If something better, then you can do. Beta, should I start next topic? Are we better? Should I start next topic? Ah, okay, fine. So, bacha, I can see beta put the heading here. Source. Students put the heading student. That is what source. Student, you have to put the heading. That is what source. Right. Okay. Bacha, I can see for source. Okay. Source bacha party. A body which emits a body which emits light is called source. Simple beta. A body which emits light called as source. Okay. So beta we have many kinds of I can say variety of source beta. So you can write first beta. This is self-luminous. This is what beta you can see self-luminous. Can you write here example beta for self-luminous? Those source which possess light of its own. Now beta example what you can write? Student you can write as example. This is sun, candle, etc. Right beta? Okay, beta next here self-luminous. Then beta you can say non-luminous. This is what, my dear? Non-luminous. It is a source of light which does not possess light of its own. Example beta, tell me. Tell me, Chapati, what is the name of this one? Source of light. This is what you can take. Moon. Moon doesn't have its own. I can say brightness, right? So moon bacha. Then beta, what you can say? Object around us. You can take a book. You can take a what? This is textbook here. You can say this is what? Textbook, etc. Right. Next beta is the point number beta third. This is beta I can say ray. There are many variety here I can say, but just leave it. Next beta, put the heading. This is what ray. So what's a ray? Straight line path along which the travel. The straight line path along which the light travels between points in a homogeneous medium. Just keep in mind is called what? Also you can say this is what? Law of rectilinear propagation of light. So law of rectilinear propagation of light what says? Light what says? Light travels straight line in a what? Homogeneous medium. Light travels with a straight line what? You can say in homogeneous medium. Light what travels between straight line which is what you in a homogeneous medium. Okay. So now bacha, just next reading. You can just no, I'm just not leaving any bit of the point bacha. Next you can say this is what? Medium. Okay, substance through which light propagates or tends to propagate. Substance through which light propagate or tends to propagate. Beta, what you can see? Medium. Now, beta, I can say for medium here, you can think beta, there is a variety of medium. So, with this is transparent. What beta party? This is what you can see. Transparent medium. It is the medium through which light can propagate. It is the medium through which light can propagate. Bacha, tell me example. This is glass, water, etc. Next picture, tell me here, what's the opaque? What is the opaque? What is the opaque? It is the medium through which light cannot be propagate. Example bachcha, example, Hari Krishna student, how are you beta? You got delayed to join the class. Okay, opaque beta. It is the medium through which light cannot be propagated here. Example, what you can write bachcha? Basic point I covered beta. SR01 beta. Anytime you can watch. Student, I'll upload as it is same video on YouTube. Now bachcha, you can say wood, iron, etc. Okay, my dear. Now, bacha, have a look next year. I can say what is the beam of light, or I can say bacha translucent. You can also see think translucent. SR01 beta. Can you tell me what is the example of translucent? What is the example beta for translucent? SR01. Advik. Anyone from all of you? Anyone those watching the video, answer me. Translucent. Anyone? Oh, wallpaper. Correct beta. Correct beta. Correct bacha. You can take example beta for translucent. That is what? While paper. Then what it is? Tell me it's ground glass. You can also say this is ground glass, etc. Right bacha party. Okay. Then bacha, let's go through next. That is what you can see. Beam. This is what, my dear? Beam. Okay, fine. So what is the beam, my dear? Yes. Advik. Correct. Advik. Yes. Correct answer, beta. Correct. Very good, beta. I'm very happy to see, bacha. Okay, beta. What is the beam? Okay, a bundle or bunch of ray is called beam. A bundle or bunch of ray called a beam, bacha. So first, beta, you can say a bundle or bunch of rays is called a beam. Okay, so there are a variety of beam here which you can keep in your mind. So this is, students, I can say first one, parallel beam. This is what, my dear? Parallel beam. Okay, so what is the parallel beam here? It's nothing here. You can see it is beam in which all the rays continuing the beam move parallel to each other. Yes, beta, and suppression also remains same. So this is what I can say parallel beam. My dear, you can see this is what parallel beam. Okay, next body I can say convergent beam. This is what, my dear? Convergent beam. Okay, so you can take it. There is an obstacle. There is an obstacle. Okay, now which I can say a ray is coming like this. Students, a ray is coming like this. So this is what convergent beam. You can take it in consideration. This is what, my dear? Convergent beam, right? In this case, what is which about it? Diameter of beam was decreases. In this case, beta, what it is? That is the major point here for this one. For just keep in your mind for numerical bacha. For convergent beam, what you can write bacha for numerical diameter of beam. Diameter of beam, what I can say? Decreases. Diameter of beam, student, what you can say? Increases. Beta, God bless you for your reaction. diameter of beam, what are students, you can say increases, sorry, decreases. Now what's the next is what I can say divergent. Students, next I can say this is divergent beam. Okay, so what is this? What's about it? It is a beam in which all the rays meet at a point and being produced backward. Diameter beam what goes increasing. But I can take care. This is what obstacle. This is what, my dear, you can say obstacle. So beta for this condition literally change. This is student source. Beta for this condition you can take source at infinity. That source beta what you can say beta here infinity, my dear. But here bacha you can take this is the source. So source light falls over here. Next beta light falls over here, right? And finally beta what you can say diameter of the beam is what increases. If diameter of beam increases bacha, then what you can say this is what divergent beam. What you can say this is what divergent beam. Okay, now bacha next year we continue object and image. What student, what is the object? I hope all of you remember, but I don't want to leave any weak point here, right? So what we can see for object, we can define object as the what point where incident ray intersect or appear to intersect. So again I'm repeating here, what is the object, you can better understand like this. Basically better object we can treat in two different ways. This is what real object, and next beta what you can see this is virtual object. Okay, so now I'm telling you how we can show real object. This is what made here real object. Okay, so let's beta I'm just initially considering student, I'm initially considering bacha, let us suppose this is the plane mirror, my dear. This is what you can say plane mirror. So this is the source beta, so light falls over here, light beta is what falls over here bacha party, right? Okay, so this is what beta I can say a real object. What is the beta definition of object here? Already I said light intersect, incident ray intersect or appear to intersect. That is beta what we can say bacha party real object. Beta you can take example, I can say beta for next year concave mirror. This is what my dear concave mirror. Okay, so again you can take bacha, there is a source, so source light falls on a mirror. So this is what you can say real object. This is what my dear you can say real object. Okay, first, second, student third one here. Now student this is next one convex mirror. This is what made here convex mirror. Okay, so here again you can take in consideration students, this is the object, this is object, and now ray falls over here. So these are the example beta which I gave for what I can see real object. And what is the object? We can define object as the point where incident ray what intersect or appear to intersect. So this is what my dear definition of object. Now here have a look, I can say bacha. Okay, no but this is a real object. As I said, we have what again bacha virtual object. So now students I wanted to draw a diagram of, I can say this is what beta is virtual object. So but as usual now initially I'm considering my dear it's a plane mirror, then concave mirror, and this is what my dear convex mirror. Yes beta, this is plane mirror, concave mirror, and this is what you can say convex mirror. So bacha ji, this is the condition. which you can keep in your mind. This is the convex mirror. This is what, my dear? Convex mirror. Okay, so again beta, you can, let us suppose light coming from infinity and light meeting at this point. So this is what, my dear, you can say, this is what you can see, virtual object. What, my dear, you can say this is what, virtual object. Okay, next beta party, I can say beta for this is concave mirror. So beta for concave mirror students, again you can take same consideration, light coming from infinity. Beta this is I can say virtual object. This is what, my dear, virtual object. Okay, beta same thing, you can draw diagram for this. This is a ray of light again coming from infinity. Now students, meeting at this point, what you can meeting at this point, which so these all are beta which I give example of virtual object. Beta take snapshot here and which I give student here. This is what example of real object. Example which a party for real object. Okay, fine. Beta just after this student, because we have finished object, so what is the last basic point? You can call, my dear, this is image. Go. Yes. Very good, beta. Advik, beta. Go, bacha. Go, beta. This is what, image. This is what, my dear, image. Okay. Any optical image is a point where reflected or refracted rays are reflected ray, bacha, what, light either intersect or appear to intersect here. So again beta, I can say image can define in two ways, bacha, but the same definition, bacha, which I can say, I said for object, appear at a common point or appear to meet. The same thing for image, beta, after reflection or refraction of, I can say, ray of light at what, intersect or appear to intersect. So this is what you can say image. This is what, my dear, you can say image. Okay, so image again student defined for two things. This is real image and which are, this is what, virtual image. Real image, which are what you can say, this is the virtual image. So beta first I'll discuss here. That is what, my dear, this is real image. This is what, my dear, real image. So let us suppose there is one ray. So this is what, students, points where you will get image. So this is what, a real image. This is what, my dear, real image. Okay, next beta example you can take. This is the first example of real image. Because this is, I can say, next example of real image. Okay, yes, bachaji, for this condition you can take as a plane mirror. This is the what you can say, source. This is what, my dear, source. So light falls on a mirror and bent reflect back. Light again beta falls in the beta, what I can say, bent in a reflect back. So this is what, my dear, this is what, my dear, you can see a real image. This is what, my dear, because no, here this is ray at infinity. Rays is what, infinity. So this is, I can say, for real image. Now beta, I can discuss about virtual image. So what is the virtual image, students? You can take in consideration as a plane mirror. As a plane mirror. So now beta, I'm writing here only beta. So beta, let us suppose this is a source. This is the source. So source light beta what falls on the mirror. Source light beta, what you can see, source light falls into the mirror. So now beta, it's a reflect back. So this is what, my dear, you can see virtual image and real image beta. After this beta, I can see little point which I'll discuss in detail here. That is time came to discuss reflection of light. That is a major point, my dear. That is what, my dear. Next point. This theory is finished almost, you can say. Now coming point, it's literally pretty good. Coming point beta, it's literally pretty good. Okay. So what is the topic here? Next topic, my dear. Law of reflection of light. I explained 3 law only. Now this is the 4th one, and remaining will have, that is one more here. So beta, this is a reflection this is what, my dear, reflection of light. Okay. So beta, what is the things here? Reflection of light. No, I can see all of you already know previously also. It's very simple, my dear. What you can say, let's try to understand. You can take here any of the materials, right? Now friends, you can see light. This is incident ray, my dear. This is, friends, you can say normal. This is what, incident ray. This is what, my dear, reflected ray. This is an incident ray, this is a reflected ray, and my dear, this is what you can say, transmitted ray. So this is, students, incident ray, but this is a reflected ray, and this is what, my dear, incident ray, reflected ray. This is, but I can write transmitted ray. Okay, transmitted, or but I can also write here this one, refracted ray. This is what, my dear, you can say refracted ray, transmitted ray, or you can see this is what, refracted ray. Okay, so beta, this is what, reflection of light. So in the reflection of light beta, I can also add more point. That is, students, I can say law of reflection. Law of reflection. Okay, so students, for law of reflection, according to law of reflection, what can you say, bacha? The incident ray. What bacha party? Incident ray, normal ray, and reflected ray, and the what? All lie in a same plane. And what beta, we can, this is law of reflection number 1. Because this is what you can say, law of reflection number 1. I'm not writing here. This is very common. I hope you know already. The incident ray, reflected ray, and what beta is normal ray, all lie in a same plane. So this is what you can see, coplanar plane. This is beta what you can see, coplanar. Okay, fine. Next is about the this plane is also called as plane of incidence or plane of reflection here. I wanted to write what's about this point. The incident ray, the reflected the incident ray, beta g, the reflected ray, and the normal all lie in the same plane. So but I know if there are many rays lying, I can say on the same plane. So this is what but I can say coplanar plane. beta what you can say idea, this is what coplanar plane. Okay, beta this plane is known as beta, this is the point which I wanted. Because of this point I'm writing this much. I wrote this much here. This plane is called plane of incidence. Beta on a ray is falling by body where incident ray, normal ray, reflected ray all are lying in a same plane beta. So this plane is beta G. This plane is called the plane of incidence. This plane is called beta what? The plane of incidence, or beta G, plane of reflection, or beta plane of, or beta you can say what, plane of reflection beta, both are remain same here beta. This is law 1 beta for I can say law of reflection. What's the law number 2? Let's see law number 2 what says, the angle of reflection is equals to what? Angle of beta. This is law of reflection, law number 1 beta, which I wrote. Now which I'm writing here, law number 2. The angle of reflection and what you can say, angle of incidence, both are remains same. Angle of reflection is equals to what? Angle of incidence, both are remains same. So this is what you can say, law of reflection now number 2. Okay, so you can also draw all the things which I said. You can take any random plane. So you can take any random plane, and this is you can take in consideration, this is polished surface. This is what, my dear, polished surfaces. Okay, now this is what, normal, my dear. This is what, my dear, normal. So you can say this is what, incident ray. This is what, my dear, incident ray. This is what you can say, reflected ray. Beta, this is incident ray. This is what you can say, reflected ray. This angle is what, my dear, I, and this is what you can say, R. So beta, here you can write angle of incidence. So what, angle of reflection, because of law of beta reflection number 2. Okay, so beta mathematically you can write sometime students, I can say they ask these questions. I like it as a objective question. So mathematically, yes, but I can write, because no, but because you will learn, student, you will learn scalar triple product. Scalar triple product, student, that is what I can see, part of mathematics, coordinate geometry in 12th class. You will learn as students. Now just keep in mind, if we have a 3 you can say vectors, so we can arrange in this format any 2 of the in cross product, because we have a 3 vectors. In 3 vectors, any of these 2 you can take is like say beta dot cross product, and third one is what, in dot product. So you can say this is I cross R dot and cap is equals to 0. Second beta, you can say this is I is what, incident ray, R is what, reflected ray, and is what, normal ray. Beta, here you can write here reflected rays, and beta G, normal ray, is equals to what we can say, I vector, which is equals to 0. Options number 3rd. These are not options. This is a way to write if we have a 3 rays, and these all 3 rays what, lying in a same plane, then you can make a frame a formula like this. So students, you can say I cross n dot r vector is equals to 0, is equals to 0. So these all are beta, what you can say, this is known as scalar triple product. You have freedom here, you can just take any of these 2 in cross product, remaining what you can see, dot product. So scalar product, I can say a scalar triple product. I hope you got it, everyone. So this thing here, beta, I wanted to represent here in terms of like, uh, so that you can easily understand. Uh, this is what my dear, you can write. This is the normal vector. This is incident vector. This is what reflected. This is what my dear reflected. So I can say which this is what theta. This is what theta. So now which this is incident ray. I cap bacha. I'm considering over here. This is beta n cap. It's a what n vector, and beta this is what r vector is equals to what r cap. Okay, so these all beta mathematical formula I can write over here. Okay, then what's our next year? Concept of ray changing the medium. But I hope all of you written here. Okay, please what's concept of ray concept beta. Which kind of concept we are going to learn? If ray changing the medium, if ray changing the medium, yes beta, very good for your reply. Yes, if ray changing the medium means beta I can take in consideration like this. Let us suppose you can understand beta I can take any of the plane. Good beta. Now beta I can say this is what students basically good beta. Now beta this is normal rays. Beta you can take in consideration this is incident ray. This is incident ray. Here I'm considering v1 is speed of incident ray beta. Beta this is what lambda 1. You can see wavelength of incident ray. Next students you can see this is what f1 is what frequency of incident ray. Now let's talk understand this is what ray reflect back into same medium. If incident ray has a speed v1, wavelength lambda 1, frequency is f1, and ray reflect back into same medium. Students, ray reflect back into same medium. So which I can say for this condition, and beta one thing you can also think this is a reflection which if ray traveling from rarer to denser, you can take with for consideration, or you can take medium 1 and 2. This is medium 1, this is medium 2. So if the ray is what traveling with a rarer to denser, what you can say refracted ray towards the what we can say towards the normal air. What I can say towards the normal. So now which here we have to comment what is speed of this wave, means you can say refracted wave, and next bachas you have to also comment what is the wavelength and what is the frequencies. What is the wavelength and what is the frequencies. Okay, bacha party for this condition let's take in consideration beta one thing, just note down everyone. Note, frequency depends only on source. I repeated multiple times this God bless you bacha. Now I can say beta ji for next, this is what beta ji frequency is frequency depends on source only. What my dear? Frequency depends on source only. Frequency is independent of medium. Beta note number 2. Beta this note number 1. Note now. Frequency depends on source only. Beta next. Color is a property of frequency. color is property of frequency. Color is what? Property of frequency. Student, God bless you. Next beta, I can see point number 3 here. Note beta, note down everything. Frequency is independent of medium. Frequency is independent of forever students. Okay, now beta I can see the points. We can go through mathematics little. So here you can write by party for this conclusion. This is what f1 is equals to f2 is equals to f only. F1 is equals to f2 is equals to f only. If ray traveling one medium to another medium, frequency remains same. If ray traveling one medium to another medium, frequency remains same. Okay, fine. So beta, just using formula here so that we can get result. Just now beta, I can say beginning of today class already I said everything beta. So this is what beta, using V is equals to lambda f. V is equals to lambda f beta. So lambda you can write what? V upon f. So you can write with V1 upon lambda 1 is equals to V2 upon lambda 2. Right, bacha? Or you can also write what? V1 by V2 is equals to lambda 1 by lambda 2. Beta ji, V1 by V2 is equals to beta lambda 1 by lambda 2. Beta, you know, highly important students. Literally here it's highly important. Okay, beta, what is, just put the next heading here which I said previously. I'll discuss in detail, my dear. So this is concept on refractive index. Concept on what beta ji, we can see refractive index. Okay, fine. So what is formula beta? C is what beta ji? Maybe you know, otherwise remember here these all points from electrostatics only beta. I hope all of you finish electrostatics. So C is beta what? 1 by mu naught epsilon naught. Mu naught is what? Permeability of free space, and this is what? Permittivity of free space. So beta, I know what is mu naught here. Mu naught you can write with party. I want to write once here. Mu naught by 4 pi. This is what? 10 to the power minus 7. And students, epsilon naught, I hope all of you remember, 8.85 10 to the power minus 12. Right, beta, just feed these values over here. So we will get C is equals to 3 into 10 to the power 8 meter per second. C is equals to what, my dear? 3 into 10 to the power 8 meter per second. Okay, so this is beta C defined only for what? Air. Only for what, my dear? Air, right? Now students, I'm going to God bless you for your valuable and kind words. Now bacha, I'm going to write C for medium. Now bacha ji, I'm going to write C for medium. Okay, so what's better I can write here? C for medium, it's nothing but, this is what, my dear? Mu r epsilon r mu naught epsilon naught, right? So sometimes beta, just you can manipulate further. C medium, what you can write? This is C upon beta g mu r epsilon r. Now beta, I can write here C is what beta? C medium, C upon mu r epsilon r. Okay, बच्चा जी for further here, now onwards just keep in your mind, C for medium, it's nothing but C upon mu. C for medium beta, what you can write? C upon mu. बच्चा literally it's highly important. बच्चा जी it's highly important यार. Okay, so there are few points which I wanted to tell you here. I can say it's a relation. Students, it's a, you can say, relation between v1, v2, lambda 1, lambda 2, and mu1 and beta g mu2. mu1 and beta, you can say mu2, right? Okay, so just keep in mind everyone, it's every years they asking these questions, this formula every year asking me at this formula beta. So keep in mind everyone, v1 upon v2, which is equals to beta c1 upon c2, which is equals to beta, what you can say, this is n2 upon n1, or beta you can just remember this thing also, v1 upon v2 is equals to lambda 1 upon lambda 2 is equals to refractive index mu2 by mu1. So this is the point beta. Literally JE asking regularly, my dear. JE student asking regularly, bacha. So keep in your mind. Okay, here I wanted to tell you something more. Bacha, take snapshot here. Take snapshot, my students. Okay, I hope you have taken already. Now, Chachi, here maybe they can ask someone. I can say, Bacha, this is a question asked by JEE 202026. Just imagine. Formula only. Till now, I didn't started. Till now, my dear, I didn't started here. I can say like any chapters or any particular topic. Till now, I'm covering. Till now, here I'm trying to cover only basic point, and on basic, Jay already asked the question. Already I have written. Already I wrote a student that you are J 2026. This is students. I can say I'll write more here. 2026 as J main 2026 ask these questions directly straightforward. Betaji directly and straightforward J ask these questions. So keep in mind how important the basic of any of the chapters. Not I can say about like this ray optics. Any of the chapter you have to always try to put your attention to learn from basics only, right? So beta, what is formula here? Lambda for medium. Lambda for medium. Beta what you can write? Lambda in beta you can say air upon बच्चा refractive index. Simple यार. Lambda for medium बच्चा what you can write? Lambda in air upon beta what? Refractive index. Right. Sometime beta they can also ask here. This is number of waves. Number of waves. So this is what would say about it? As a formula, keep in your mind. This is T into beta refractive index upon beta wavelength in air. So beta, this is the formula already asked by J2026 beta. So keep in mind number of wave beta, what we can say, T into mu upon beta what? Lambda naught. T into mu upon beta what you can see, this is the lambda naught. Okay. Then which I can say there are many waves here, many reflections, right? Types of reflection. I don't want to waste time here. I don't have too much time. Just I'm telling what's a party. We can also remember types of reflection: regular, or you can say specular reflection, and irregular or diffuse reflection. That's all. So what is but I can say regular reflection here means like just I wanted to clear once. Just I'll draw little diagram. Bacha, so here you can say types of reflection. That's a types of reflection here. So student, for this condition here, what we can say bacha, light ray falls. But this is telling bacha about regular reflection. Okay. uh, Now bacha see, this is beta light ray falling over here and go beta by. This is beta what you can say, regular reflection. Yes beta, right. Next beta, this is what I can say, second one, irregular. Irregular reflection. So no surfaces, but I can say for this condition you can take this kind of surfaces. Yes beta. So this is what for this condition. How can you show? Yes beta, look like this here. Beta coming like this, right? So different, it's not I can say in sequential. It's not beta what you can see in sequential here. Okay, so now student, after this here, that is I'm going to discuss. I can say for in basic, what is the things which you can keep in mind later. This formula which I covered till now, I can say for the classes around 1.5 hours. So that is basics only, and in these all basics, this point is highly important. This formula is highly important. I can say beta, this formula each and every year without any gap, JEE asking this formula regularly, and they will definitely ask this formula. Now already I said this formula asking JEE 2026. All questions you will get from class notes of BK Sir only. So strictly follow, you will get benefit 100%. Okay, now students, have a look here next, that is vector analysis. What my dear, vector analysis of law of reflection. Literally it's a question beta, I can say one time JEE advanced, not now, very long back. In JEE advanced beta, they asked thoroughly, means there is 8 marks derivation is there, right? So I can tell you, be always pay attention to learn the concept from, I can say, zero to hero. I can say zero to hero bacha. So what's the heading here? This is my dear. Okay, so beta I can say student, God bless you. Keep following. Student, keep following. This is vector analysis. Vector analysis of law of reflection. Vector analysis of beta law of reflection, right? Okay, so listen carefully beta, I'll take time here to explain in this one. Yes beta, literally here. When asked beta this question, remember, this is the student question asked in JEE beta subjective nowadays beta they are asking only formula. Nowadays student, they are asking only formula here. This is what, 10 marks. I said 8 marks previously. No beta, it's 10 marks. 1,999 bacha they ask here. They already these questions. So now beta have a look here. How can you understand here? So bacha party, let us suppose you can take as a consideration, it's a normal plane. Okay, so now students, here I'm considering this is the ray falling over here, and students, I hope all of you know this is what my dear, normal, right? and now beta this is what reflected ray. So students, here I'm considering incident ray, which is equals to a cap, which is equals to my dear a cap, beta reflected ray, which is my dear b cap, and this is what beta I can say theta, this is what I can say what's a party theta. Now I can say this is what normal beta n cap. Student, n cap is what normal, n cap is what students I can say normal. Okay, now bacha I can say for next year. So what is the thing bacha, these all are unit vectors. So I hope all of you know beta what is the magnitude of a cap is equals to beta g, b cap is equals to beta n cap, which is equals to 1. What student, which is equals to 1. Okay, so beta for applying concept of vectors for this all analysis student, I'm going to I'll retrace this path so that I can apply vector summation law. Okay, so now students, I'm going to just retrace the path. So this is what my dear, you can say minus a cap. Student, this is as usual, there is no change, it's beta b cap. Now student, this is what normal, this is normal. So now you can say beta this is what, now we can apply law of parallelogram. Now students, you can apply law of parallelogram. Beta I can say this is what my dear, it's a n cap, this is what my dear n cap. Okay, so now students I can say this is the theta, this is what remains theta. Beta listen carefully here, this one bacha, right? Beta I'll take component here, this is what a cos theta, beta this is what a sin theta. I hope you got it. Again I'm repeating, beta j student, this is what a, so you can take beta this is what a cos theta, and this is what a sin theta. This is b my dear, so this is b, you can say b cos theta, this is what b sin theta. So you can take bacha, sir this is what a cos a sin theta and b sin theta, what cancelling each other, cancelling each other. And now beta you can say what, so this is what adding this in this direction, a cos and a cos beta, what beta both are adding in these directions. Okay, so beta here I can write it directly b cap, this is students b cap, listen here everyone carefully, student b cap beta j, this is b cap minus a cap is equals to beta 2 cos theta and cap. Now beta, why I did here 2, because 1 plus 1, and already know I have taken beta as a consideration, a cap, b cap and cap is 1 bacha. So we can write what, this is 2 cos theta and cap my dear. Okay, so here bacha party, I'll apply here formula what cos theta, how bacha party, for getting here cos theta from this triangle, beta little I'll apply little manipulation. In fact, I'll do here only here so that you can easily understand. Yes beta, so I hope you can easily understand. This is my dear normal vector, right? And this is what beta g minus a cap, this is what n cap, this is what theta, this is what theta. So I'm going to apply formula a dot b. So students, formula of a dot b, I hope all of you know, otherwise I'm writing this is magnitude of a into magnitude of b into beta cos theta here. So this is a, this is b, so here I can write my dear minus a cap dot n cap is equals to what bacha body, this is what basically cos theta. So this cos beta I'll replace from here beta, this is the value beta which I beta this value cos I'll beta feed over there, let us say equations number 1. Let us say beta students equations number 1. So you can write what's about it. This is b cap minus a cap is equals to what was that? Minus 2 a cap into beta n cap. Entire multiply by what? N cap near which this is already over there. Okay. Do beta one thing here. This a beta is take beta. I can say right side. Student, this a cap you can take student right side. So you can write over here. This is b cap, which is equals to what, my dear? Which is you can say a cap minus. This is dot here. Don't forget. So this is twice of a cap n cap into beta g n cap into beta g what I can say n cap. Okay, so beta g this thing here I can see final result, but again I'm writing on top of this paper. Student takes snapshot. Student takes snapshot. Okay, I hope you have taken. Fine, very good. Now with party I can say for the condition what is the we got here b cap vector v cap is equals to what beta? This is a cap minus twice of a cap dot n cap into which party this is what you can say n cap. Yes, bacha. So beta for further here what we can say there is this is a result beta which you can keep in your mind. This is the result student which you can keep in your mind. Okay, now it's God bless you. Beta next here I can say x by plane. Then beta if they are in this thing, this I'm telling you this thing beta I'm telling you only for numerical, yeah, this thing which party. So what you can see this is what x by plane. So if they mention x by plane, so normal unit vector vector what is if they mention x by plane, so what is the directions of normal unit vector? So students for this condition you can take normal unit vector which is equals to what beta? K cap. Means this is if we have a xy plane in the question they will mention student in the question they will mention xy plane, so you have to take directions of normal what according to plane only. So this is point number 1 beta. Now point number 2 beta ji, let us suppose I'm calling this is by z plane. So you tell write anyone direction of normal vector, direction of normal anyone write what's party? Anyone those watching the video? Those what okay. Okay, correct beta. Okay, x yz plane beta. What is remaining we have? If we have a yz plane, what is remaining we have? Only x. So answer very good here, very good. So you can say bacha normal unit vector. This is what I cap. Simple, it's very xy you have taken. What's remaining? Z what implies k cap. Now bacha you can say next this is what yz plane. If you are talking this formula is literally highly important. Nowadays they are asking formula only. So keep in your mind if this is the yz plane, what is remaining? We have only x. So what's answer? I cap. Beta third one you can keep in your mind. That is students you can say this is zx plane. This is what my dear zx plane. So zx what is remaining we have only y. So students just answer me quickly here. Normal unit vector direction. Beta what you can write? This is what j cap. This is what my dear j cap here. Okay, fine. So this is all about beta theory which I have done today. Now I have a time only 14 minutes. I'll do only numerical. So be active, answer questions quickly. Okay, take snapshot bacha body. Okay, fine. So have a look at questions. Here you can I can say test yourself what you learned, right? So bacha party, this is a question, sir. Just keep in your mind. Let us suppose I'm giving you, my dear, a cap. It's just keep in your mind what they mention, a cap only. So I can take anything here. It's easy data. 3 I cap plus beta g 4j cap. 3 I cap plus beta what I can say 4j cap. Okay, beta I and j. So beta they mention already, beta I can say directional vectors. Yes, I remember. Huh. Beta normal vector direction beta they mention here. That is what j cap only. They are find b cap. They didn't ask vector. They asked find b cap. They asked bacha find b cap. Answer me, anyone from all of you. Anyone from all of you answer me. Simply, you can apply the things which you learn. You can apply the things which you learn the formula directly. Simply, beta, you can apply the formula directly, bacha. Beta, as I'm remembering, beta, this is a vector, yeah. It's a vector. Yes, beta. This is a vector. Anyone from all of you? Okay, I'm solving here. Time is very less. Listen here. Listen, everyone. Attention here only, beta. Listen. Okay. So, beta, I'm going to use first, beta. I'll write the formula for b cap. This is what, my dear? A cap minus twice of a cap dot n cap into what you can say n cap. This is a formula. Just check once. Correct only. Correct only, beta. Okay. Now, students, I can say for this condition here, how can we do it further? So this is a vector, beta. This is you have to write what beta you can say. This is a cap. So beta, you have to just first find a cap vector here. So I hope all of you remember how to find unit vector. So unit vector is nothing, beta. You can say this is vector upon its magnitude. Vector upon its beta what I can see magnitude here. Okay, so this is beta g vectors A. You can write 3I cap plus 4j cap upon beta. What's the magnitude here? I hope all of you remember. I hope all of you remember how to find magnitude. Coefficient of x whole square plus coefficient of y whole square. So this is what beta I can say simplify here. So here you can write beta a cap is equals to 3 by 5 I cap plus 4 by 5 j cap. Very good here. So now bacha again here I'll use equations number 1. Students, you can see step 1 I finished. This is what, my dear, step number 2 beta. This is what, my dear, step number 2, right? So bacha ji, this is b cap. Ikke bacha I can write 3 by 5 I cap plus 4 by 5 j cap minus twice vectors a dot n bacha. So n beta what I can see j cap here. So no need to write beta entire. Now bacha party here, no need to write here entire bacha party. So this is what bacha I can say for this condition bacha party. A dot and n bacha, we can just multiply bacha party, right? A dot and n vector. So this is do beta individually a cap dot n cap. So a cap beta what we found? Yes, this is now. So beta write 3 by 5 I cap plus 4 by 5 beta j cap and n cap beta in j cap here. So I hope all of you remember bacha party same dot product beta, same dot product 1 and beta opposite 0 bacha. So what you can write finally, sir, this is 4 by 5 only. This is beta what you can see 4 by 5 only. Okay, so beta this thing here you can just put over there because this is a dot n bacha. So this is 4 by 5 into beta j cap here. So this is bacha party j cap. Further here you can solve for beta g b cap. What you can say beta 3 by 5 I cap plus 4 by 5 j cap minus here 2 for the 8 8 by 5 j cap. Simple. Now beta just leave it here, vectors b as it is I cap, no need to do any further changes. Beta here you can take bacha party further here. Beta what you can do bacha party 5 5 everyone here, so 8 minus 4, so you can do bacha 4 minus 8 j cap upon 5. So beta b cap you can write 3 by 5 I cap minus 4 by 5 j cap. Yes beta. So this is the answer of the questions. Student, this is the answer of the question. It's literally beta not tough here, only vector application. Students, it's not tough here, only application of vectors. So these things literally highly required. This thing beta I can say literally highly required. Okay, I hope all of you done. I hope all of you done. If you finish with writing work, just write in chat works, or better I can show you reaction here so that I can understand. Okay, so now beta I'm going to do next questions here based on same profile. Okay beta, got it. Same beta ji next profile here. Students, again you have to find beta g b cap if vectors A is equals to 8 I cap plus 4 j cap. Beta normal vector which I can take, normal vector which you can take, that is yes beta 4 j cap, or simple beta I can say j cap. You can take bacha. Normal vector is what? Only j cap. Questions remain same bacha. Find b cap. Questions remain same bacha. Find b cap. Okay. Just do everyone here. It's not a tough question at all, my dear. Right? You can do these questions. Yes, beta. You can do this question here. It's not tough at all. It's literally very easy question. Do everyone, or I have to do? Okay, I have to do. Why? It's not a very tough questions. Yes, literally it's not a very tough questions. Okay. Sir, voice. Sir, voice. My voice is not. Repeat. Okay. You have to find v vector. Sorry, you have to find b cap. You have to find v cap. Okay, I can say very few students today watching. It's a ray optics. Okay, now students just go for solution. Now students go for solution only. Okay, so beta first you have just write formula of b cap. It's nothing but a cap minus twice of vector a dot n cap into n cap bacha. Let us say, my dear, equation number 1. Okay beta, maybe there is some technical glitch. So student, first you have to find a cap. Step 1 beta, a cap you have to find first. So this is vector a upon its beta, you can say magnitude. So vectors a is mentioned, student, 8 I cap plus 4 j cap, and this is what beta you can say remains 10 only. So you can rewrite beta a cap vector 8 upon 10 I cap plus 4 upon 10 j cap So this is vectors A. uh, God bless you beta. Vector A, this is what you can say, 4 by 5 I cap plus beta 2 by 5 j cap. Okay, now beta we found vector A. Beta we wish to also find here eta A cap dot n cap. So in step 2 beta I'm doing my dear A cap dot n cap bacha. A cap is what we can say, 4 by 5 I cap plus 2 by 5 j cap. This is remains j cap bacha about it. I hope you remember same dot product beta one only, right my dear? So this is A cap dot n cap beta how much? 2 by 5 only. 2 by 5 only beta. These all values I'll feed in equation number 1 my dear. So this is B cap. A cap already have found, 4 by 5 I cap plus 2 by 5 j cap minus twice into beta. This is already we found here, E cap n cap. So this is 2 by 5 beta and this is what, j cap. Simple. So it can be the 2 to the 4 you can write, 2 to the 4 my dear. So this is 4 by 5 I cap plus 2 by 5 j cap minus 4 by 5 j cap here. So this is beta minus 2 finally as answer. You can write my dear for final answer of these questions, 4 by 5 I cap minus 2 by 5 j cap. So student, this is answer of the question beta. So now student, this is all about today class. Yes, there is assignment I can tell you beta. You have to practice this part only, each and every one beta, practice this part only. Remaining beta I'll see tomorrow. God bless you everyone to join live session at physics point.